All right, so welcome everyone to this third part of a four-part series where we're talking about farming for profit. And our primary focus with this event is really to help you as a consultant, as a farmer yourself, or maybe just someone who's really interested in this part of agriculture to join in and see how you might be able to, farm for profit or help your farmers farm for more profit. And that's one of the things that we're really learning a lot here. And every time I speak with David and Sloan and Brad Forkner, I'm learning more. And of course, when we have ideas, sometimes we have to be open-minded enough to change those ideas on occasion. And that's one of the things I'm learning as I continue to work with both of these guys. The way that I think and the mindset that I have is expanding. We're learning a lot more, we're growing a lot more, and we're preparing for a lot healthier profiles. We're preparing for a lot more profitable profiles. So I appreciate you guys jumping in. With that being said, David Sloan will probably kick us off as we just look at a little data to think about as we're driving into pollination season. And David, if you want to get ready for that, what we'll probably do is have you present a little bit on some water elements, and then we'll stop and have Brad give some feedback on the nutrition management at that time. When we were doing some prep work, we noticed that there may be different times during pollination when we may forget that our nutrition management and our water all flow together, and we need to have things working in sync. So, David, the floor is yours. What do you want to share with us today?
Okay, thanks, Kylan. It's funny, you always talk about preparing for pollination. I talk about setting yourself up for success. But
Mhm.
either way, what it means is the peak water use is coming. And so that crop, and I'm not telling anyone anything new, I'm just setting the background here. And can you hear me okay?
Yeah.
So from about 10 days to 2 weeks before tassel to a couple of weeks afterwards, we get into that peak water use period. And it's most people know that, but why is it the crop using so much water? Well, if we have a look at, to remember, or just to explain that from the root perspective, crop perspective, for those of you who've been following along the webinar series, have explained soil moisture graphs and how we see stair stepping. So the crop uses water during the day and it rests at night. So these stair steps actually show you how much water the crop is using each and every day. And so we can see there are small steps, and then they get into very large steps, and then the steps get smaller again. And so we can actually see this period where it gets extremely large right at either side of tassel. And so the crop is doing what it needs to do. It's trying to keep up with that peak demand, as we saw with the water use curve before. Thing is, if you don't have water available at that time, then things can go wrong. So um, little plant physiology. If we look at how the crop reacts to water availability, this is an old graph, and it's probably from a flood irrigated example, but essentially what we're saying here is full point, the soil is wet, and refill point, is a point where we're going to obviously irrigate in this case. But two things going on: photosynthesis, cell production, and cell expansion, which is self-explanatory. So if you think about what's going on, and you're trying to get rapid cell expansion. So a good example here is growing grass. If uh, I can still have maximum photosynthesis and produce the same number of blades of grass, but if I let the soil dry out, they're just a little smaller, so not as long, not as wide, because the cells aren't as large. If I keep that soil topped up close to its full point, then what I'm going to get is a very large cells and therefore very broad blades of grass. They're going to be longer. It's just vigorous, lush growth. And so I can still use the same amount of water. It's just what the crop needs to keep up with cell expansion is actually it needs, it's going to take a lot of water out of the soil. If the water's there, that's great. But if it's not, then you run out of the cells don't expand as well. And what we end up with is, I'm just going to flip through here, a problem which, if you look at drought stress at different stages of growth versus susceptibility, if you get temporary drought at these different stages, you can get it's a yield loss graph. So you can have a 50% yield loss by having stress at tassel. So why am I telling you all this? If you bring it all together, at tassel, you're trying to push the tassel out of the ear. Silking, you're obviously trying to push silks out of the ear. If those things don't happen, then you're going to get this yield loss. Well, in order to push the tassel up and the silks out, you need that maximum cell expansion. You need to have good moisture availability so that you get those very large stair steps. And if that doesn't happen, then you're not going to get the true pollination that you're looking for. And so when it comes to that moisture availability, we've got to have two things. You've got to have water in the soil, and you've got to be able to get the water out of the soil. And so when it comes to getting water out of the soil, basically the corn plant, grows roots up until tassel. And then it tends to, it puts its energy into reproduction rather than growing roots. And so what you get up until tassel is what you get through tassel. And so you need to prepare that crop for pollination by growing those roots in, but also having full soil profile. So it's a tricky thing to do. And we've got a couple of examples here. And what a lot of irrigators do is they get scared and they say, I don't want to get behind. Just looking at the root graph another way, we can actually see here that in this diagram, I think this came from the Pioneer crop growth book. I'd need to double check, but we can see the roots are going down until we get to tassel. And then pretty much from just probably 10 days out from tassel, it's no more root growth until we get into grain fill. And so what that actually looks like in a graph is where those roots are going down and then they go along. That's the same graph I showed you before. So while the crop is using all this, it's got a high demand for moisture, it's not actually growing roots to get there. You've got to have the roots there to start with. And then you've also got to have the moisture there as well. So really tricky in a dryland situation. But if you've got irrigation available, then you can at least do something about it. Before I get into some real world examples, I'm just going to pause there and see if Brad wants to jump in, or Kylan, talking about the setting up this plant.
So I'll go ahead and comment here. What I am viewing what we went over putting this thing together, is that if our roots are pretty much going to not be growing anymore during the pollination in early fill periods, then we have to have nutrition set up somewhere between V6, V16, V18, but definitely pre-tassel, because people tend to a lot of times think about a foliar as a rescue, and we cannot afford to get behind. I mean, they always say don't let the crop have a bad day, right? So they never say go out and rescue. Same with raising a child. We don't want to go out and rescue our child every time he gets into trouble. We want to have him prepared going into it. Kylan?
Yeah, I think one thing that I might have you touch on, Brad, is, David made mention this is harder to do in the rain-fed environment than it is in the irrigated environment. And that is true to a certain extent. But sometimes in the irrigated environment, we get a little carried away with too much water too soon. We don't think as much about our holding capacity, because we've simply become accustomed to pushing the start button and having instant water. But could you speak on to, again, this goes back to prepping to pollinate, but I think it's important for us to touch on, is the importance of a high water holding capacity soil that also has the ability to develop a deep, strong root system. Can you touch on that just briefly?
Yeah, let's go back and talk about that because things I was reading this morning that kind of intrigued me is when we were talking about acidic soils, those where we're getting some salt buildups and definitely some of Texas, some of Western Kansas, those kinds of things fall into that category. And one of the things that will help us to grow those lateral roots is to keep introducing very small amounts of auxins. So auxins help us germinate, auxins help us take off. Let's go back and touch just a minute on getting to this point. If we are short on phosphorus during this growing period as we're approaching the pollination time, if we're short of nitrogen, some of these other micronutrients, we are going to continually mess with the perfect example of having the shoot growth or the length of the stalk in relationship to the roots. And we don't want to have too much stock and not enough roots, to get us to that point. We want to have as large of a digestive tract going as we can to start with. Also, especially on the irrigated side, if we over irrigate, we're going to lose our oxygen. We have to have oxygen to move nutrition. We also have to have some water to move nutrition, which kind of led us off down just a little bit of a rabbit trail that we talked about pieces of Texas, and we could also have included Southwest Missouri, where I grew up. We know we're going to have moisture typically until about the third week of June. Then we could be short and maybe not get a lot of rain again until August. So maybe we need to adjust some of our planting intentions and our hybrid selections based on when do we have moisture if we don't have irrigation? When should we then pollinate? And if we're not going to have much water after that, are we going to choose to have something that flowers early, fills early, and gets done before we're out of water? Are we going to go the other way and say we're going to have something with a really long fill period, get beyond that first set of missed rains, and then catch all the water we can going into that fill period with a very full flex ear type situation on the corn or a later season bean so that we can take advantage of trying to fill when the moisture and the nutrition would line up again on the backside of things.
Okay, so I guess I'll keep going with some examples here.
David, before you do, we had a question come in that said, with irrigation, is it important, or what's the importance of having, more water out front before planting in a dry condition? Would it be best to have more water out front than planting in a dry condition? Can you give some insight on that?
Yeah, roots don't grow into dry soil. So if you want a deep root system, you've got to have deep moisture. That's the only way you can get roots to go deep. And so then you could say, well, hey, I'm using it all up front too much, but it's the plant does tend to well, I mean, I was going to say this is an irrigated example, but it'll tend to regulate itself if it knows that more water is coming at a certain interval. But yeah, you need to plant on a good profile, or else you're just not going to have that deep root system. And yes, it does very much depend in a rain-fed situation when the rain falls and that sort of thing. But it's going to there's no way you can have a really good crop if you don't plant onto moisture. You're just not going to get the roots down there. Now, it might finish on some deeper moisture, but just during that pollination period, it doesn't grow roots. It can't keep up, can't mine moisture to keep up with the time when it needs it the most. And so, at least that's been my experience, and from the textbooks I've read, that seems to be the rule of thumb. So I'm not sure with the modern. Sorry.
I say it's interesting, David, along those lines, even in the rain-fed market, our service provider down here in Texas put a probe in North Iowa on some rain-fed markets up there this year. And unbeknownst to me, he just mentioned it to me here this morning, but we looked at the data and the deep profile, the 30-inch profile and everything below that was dry. And it was really interesting as we watched the roots develop, and they caught some timely rains. The timely rains were beneficial, but the challenge is that lower profile was dry, and we're not getting a lot of recharge water right now. Obviously, we don't know what March can bring. We don't know what April's going to bring. But right now is really a time to be thinking about really where are we? We were both a little surprised to see at 30 inches. We were pretty dry down there last year.
And I
Let's
mean,
go
that's the
back and
beautiful.
talk a little bit about field tiles and the opportunities in there to put those gates in there so that as we catch rains now, and maybe a little more than we can handle in the top 18 inches, maybe slowing that water down so we give it a chance to recharge deeper, especially this time of the year. And also about, the nutrient placement, knowing our moisture capabilities. Are we going to be better off if we're a little short on moisture, keeping that nutrition closer to the base of the plant? We talked about side dressing out there in the middle of a 30-inch row, which would be the same as, where's our drip tape if we're going that direction? And same thing happens to nutrition. If we have that out of reach of the plant, then we are not being our best friend.
Yeah. So, if the roots don't get an opportunity to grow out into the interrow because it's dry, yeah, and you put the fertilizer out there, then it's out of reach, as you say. It's so that's where Y drops, I guess, come in by putting it close to the base of the plant.
For sure. David, I
So
think you have some more data to touch on this a little bit in detail,
yeah,
don't you?
slide here. I just wanted to remind you that what we're trying to do is grow the roots. And so to do that, you're actually tending to dry the soil down and then wet it up and dry the soil down, because that's how roots, if it stays wet all the time, which I will show you an example, the roots just don't they get lazy. So what we're doing is we're actually spending a fair bit of time where we're not maximizing cell expansion. But when you've got to try and wet it back up when you need it, if you can. And that's how you grow a really big crop. So this is from northwest Texas, so right up in the Panhandle, top west corner. And what's happened here is that the roots are going down, down, down. You'll see that the template also expects to have root growth, and then we're trying to hold the line and then go drop it down at the end of the season. And you can see that the roots were growing in, and we'll show you that in the next view. The stair stepping was huge. It was really, really pulling hard, and he got a timely rain. And otherwise, this was sort of heading for just trying to keep up with what was with what it needed, and it would have suffered some yield loss. This rain ended up making this a 300 bushel crop, and that was an exceptional crop, because not only did he get deep roots, but he also managed to fill it up and keep it pretty full through that critical pollination phase, and also through grain fill, and then clearly dried it back at the end of the season. Sort of perfect scenario and a very high yield. So when we look at the cutaway view of this and we see all the individual sensors, we talked about putting the water in the soil. And so this started out extremely dry at the beginning of the season, and that's back in March. You get to April, and there's some pre-irrigation, and then again in May some pre-water. Then it actually started. He got some rain, a little bit of rain, but most of the rain I think came later. This was from 2022, and so it was a pretty dry start, and managed to use irrigation to fill the profile. And we can see this gray line, the water's gone in, the pink line, the water's gone in. Then we can see the crop take it out again. And as it was getting dry, as the top was pulling really hard, the crop is actually leaning on those bottom roots until that rain filled the profile. And then it's using roots from all levels. And we can see the water is actually being able to move through the profile. But it's like having a really big motor that's you're firing on all 8 cylinders, and that's how you get a 300 bushel crop. I'll pause there in case you guys have some comments.
David, the only comment that I would have is the difference before, and you can see right where pollination was really taking place. You've got a lot of really aggressive drawdown. You've got a lot of root activity there. But after that rain event, that big rain event, it seemed like it triggered something in that soil, and the infiltration after that was a lot different. Can you speak to that, the before and after?
Well, it kept it, obviously, they had access to some pretty good water here, I think, and, watering pretty hard through that period. And, not every irrigation was making it all the way through, but he was, watering pretty hard. And after the second and third time it went around, water was starting to move through the soil. So water only moves through wet soil, and clearly, needed to, he was pouring everything he had on it, plus the rainfall, and, got the return from it. But it was because he waited and got the, things, when I say waited, he was still irrigating, but, and I'm not entirely sure if there wasn't some more rain that happened during grain fill that year. I haven't had a chance to get up really close with the farmer here, but it's, yeah, it's clear that the water is managing to penetrate all the way to depth, and the crop is using it all the way to depth. And yeah, that is
One
probably,
thing that I noticed here, David, when you look at, we've got 3 irrigation events here and 3 irrigation events there, and it took those 3 irrigation events, and we'd see this increase. We'd see the increase down here at both times, and then the plants would draw it down. You'd see that the farmer would take a break. There'd be a break in between that, and would draw that water down. The one thing that I've learned over the years is the importance of that break is, drawing oxygen back into that soil profile. If we didn't have that period to draw oxygen in that profile, we get wet, these will stay wet, and we don't really see that activity if that stays too wet too long. Is that true?
yeah, absolutely. Well, let me show you a different example where this was overwatered. And so this is up in I guess it's the northeast part of the Panhandle, and have a little more water. And this happened to be last year, where we had a lot of rain. So started out extremely dry, had to pre-water, and then it started to rain through this period and got the soil really wet. But then he pulled the trigger early and kept irrigating, and was irrigating extremely hard through that, I guess, pollination phase. But what had happened is, because it was wet early, and he never let it really set itself up, never started irrigating heavily too soon. What happened, and I can come back to this slide, but if we go forward, once again, we can look at what was happening with the pre-water, and he was getting water all the way down, and I think this was about 52 inches down. But the stair stepping was not even happening very much at the red line, which is probably, I think that was 24 inches or thereabouts. And, so below that, in fact, this was 20 inches, and I think that was 28 inches, nothing. So you're really talking about a 20-inch root system. And what's more, where we've got these extremely long tails, that's water running into the soil, but it's ponding here. We've got at that 12-inch level, it drops, comes up, and it stays wet for an extended period of time, and then it drops down again. And so this is lack of oxygen and lack of root activity in overwatered corn. And so it's a case of not wanting to get behind, but actually got way out in front of it. And we can see there's evidence it's not actually root activity down here, it's drainage, and it's probably taking some nutrients with it.
Yeah. And had he over applied nitrogen in there at any one time, that's when I come back and start talking about plugging some roots. And if we plug these roots typically until we get them replaced, or if it's late enough in the season we never do replace them, now we're not going to get that cycling, and we're never going to get caught back up keeping enough nitrogen for the optimum yield. And if the roots are plugged, not pulling nitrogen, they're not pulling anything else either.
Look at what happens when he starts to space irrigations out during grain fill, right? You can actually start to see some activity there. It even starts to work a little deeper, but it's just not bringing enough roots into play. So the opportunity was there to have a big root system, but just started with too much too soon. Now, it was wet in that part of the world during May and June, but lots of rainfall. But then once it got pretty dry later, and yet we're just keeping it wet, never letting the plant get going. And it's probably because there's just not enough oxygen in the soil, even in the second foot, certainly into the third foot. And I can see, when water goes on the top, it hits the bottom straight away. And the only way of water moving through soil like that is if it's completely wet. And so it's basically hydraulic flow, and it's just moving straight through. And whereas on that previous example, it's subtle, but you can see that some of these events, they don't make it to the layers below. It's kind of staggered, and you had to build the moisture to push it. So it's yeah.
The one thing that I
That's-
might talk into, David, on that last slide that you showed, of course, we're farming for profit, right? We're absolutely wanting to farm for profit. Brad touched on, we're going to plug up roots with this. We got to be careful that we're not plugging up roots. There's going to be a certain level of leaching that takes place here. If you really look at the combination, I know not everybody here is irrigated, and I understand that, but the combination of the potential loss of nitrogen, either through leaching or the inability of the plant to draw it in, this type of irrigation is very expensive. This is an expensive type of irrigation. Not only is it excess water, but it's a loss of inputs or the loss of the effectiveness of inputs. That's expensive, guys. We want to farm for profit. The water got to become right. And looks to me like, if I was to guess, we're probably 3 to 4 inches easily, 3 to 4 inches over applied. And that really hurt the profitability of this field, even if I don't need to see the yield data. I can see it in the root activity.
No, it's definitely, you can see when the roots got going again in the back end here during grain fill. Normally that's pulling it at much lower levels, but it's really only just starting to get going here at I think it's the 28-inch, it's either 28 or 32-inch level, and so you're not even into the 3rd foot, and there's moisture below that, but it's sitting there. So you might have lots of moisture in the soil, but you don't have the root architecture to get it back out again. And certainly it wasn't active. There was just way too much coming on through this period. It was going out the bottom, carrying nutrition with it, but just also the lack of oxygen in there. So you're stalling out the plant. And so, yeah, it's really the opportunity to actually use more of it rather than wet it up and keep it wet. Hold off until at least it gets as dry as it was previously. And there's just way too much water coming on here. What we're trying to see is more of this root activity that we're seeing during grain fill, because you spaced out the irrigation, much more, and you can see the effect of that. Plants actually much happier doing that. But
One of the things that
certainly, there you go, Colin.
David, one of the things that we talked a lot about, you've irrigated down in the Texas region where there's a lot of low pressure systems that we're irrigating right in between the rows. Some of those rows are on 60-inch spacing. Sometimes it's on 30-inch spacing. There's several elements there where we're dropping water in different places. There's also a space now when you think about nutrition management around that. And this also applies to the rain-fed market. We got to think about where the roots are, specifically where that root system is when we're putting a side dress application on and things of that nature. I've seen this mistake happen in places, in Nebraska, even at different times when we're using low pressure drops, or we get a lot of hang up in the canopy. We don't always get the nutrition where it needs to go. Can you speak to that a little bit, David, with your experience on water management?
Sure. While you were talking, I just queued up a couple of slides. Now, this is from my perspective on where is the water going. And so you got to think about this from where is the nutrition going. But, if I'm putting water down every plant row, I'm going to get a different wetting pattern to if I'm putting water down every other plant row, because I'm going to end up with dry rows out there. And so the reverse is true. So the roots are going to find the water, right? So that's also where the nutrition needs to go. I can tell you just from putting probes out that if I put a probe here, I'm not going to see the irrigation, and I'm not going to see, apart from rainfall, I'm not going to see any root activity. And so the same is true for nutrients. Now, if you're putting your nutrients in with the irrigation water, that's great, because that's where the roots will be. But if you're putting your nutrition on separate to your irrigation water, then you've got to think about that. And so, if you've had rainfall, you've got good general moisture, or if you're using a spray pattern that overlaps, then you should have a different rooting pattern than where you're having water applied close to the ground in strips. So, yeah, it all matters, and I can absolutely tell you. I can give you an example here. I'll just flip through a couple. In fact, well, the difference between the arrows here, this is a graph showing where rain fell versus where irrigation fell, and the irrigation didn't penetrate very deep compared to the rain. And why is that? Because we've got the probe actually in the plant row, and the leaves on a corn plant are designed, I guess, by nature to pull the water to the base of the plant. But if the irrigation had a drop nozzle going in between the plant rows, what we saw is that there was no water going in there. So we came back and put a probe out in the middle of the row, and what we could see, that's where the irrigation water was going, versus the probe in the plant line was where the rain was going. But you can start to see what's going on here, because here is the rainfall and here is the irrigation. So take-home message here is the irrigation was going one place, the rain was going in another, but you've got to go where the crop is looking for its nutrition. Oh, sorry, it's water. Keep that in mind when it comes to nutrition. And so the two are linked. They really are. And if you are trying to feed it at critical times, you've got to think about where those roots are active.
And I think that's one of the reasons, David, that we want to talk about these sensors. They're more about plant management tools than they are. Yeah, we might be measuring the change in soil moisture, but at the end of the day, everything I hear you talk about, it's the difference in how the stair stepping works. It's a difference in how the different the plants are responding. They're more about plant management resources than they are even soil moisture resources.
Oh, absolutely. What we're looking at are active roots. And so you got to sort of think, and what my experience has shown me is that the roots aren't active uniformly everywhere. And so the roots architecture depends on obviously the planting arrangement, but also it very much depends on where the water is soaking in, because they will seek that out. And they'll find it if given half a chance. But just like we said, roots won't grow into dry soil going down. You've got to have deep moisture if you want a deep root system. Similarly, going sideways, going laterally, they're not going to grow into moisture. But it depends on where the moisture is being applied. And so, you've got to feed the roots where they're at. And you might get differing effects from fertilization, from nutrition, just simply based on that root architecture.
Yeah. Brad, what are some of your thoughts on this as we think about what David was just showing, and your thoughts? You mentioned earlier the plugged roots and things of that nature, and the loss of nitrogen. What about in managing the soil health in this environment? If we're overly with that long, what's happening to some of our root zone we should be thinking about?
So let's go back and talk about iron with 2+. And I've kind of put together a little set of slides here that if I can figure out how to share this right fast, we're going to go down here. And I've kind of put this together so that, as the guys go back and look at this on the YouTube or whatever, they can slow this thing down and they can kind of digest some of these things on the micronutrients. Now, if you can look at the bottom of this, you'll see how everybody's vying for their spot on that clay colloid. So when I talk about getting rid of some of the heavy metals and things that are out there, even excess iron, excess calciums, whatever, excess magnesiums, excess aluminums, when we talk about using something to break those loose, using the humics then to stabilize those so we can shrink that size. That starts to let the air, the water, and the roots go down. And that also then would let the exudates come out so that we have more biology, so that we attract more worms, those kind of things. As I've tried to increase the size on this thing, it wanted to increase every slide on there. I'm going to have to get a little bit better about that. But this talks about the three primaries right fast. We're going to hit carbon, the primary energy source, right? And as I'm reading, when we have excess residue management laying out there, especially as we get toward pollination time, if we've got let's say we've got carbon setting up there in the 2 to 400, or especially the 400 to 1 range to our sulfur becomes immobile. And to kind of put that thing into perspective, corn residues at about 350. So let's go back to where we were talking about seeing a little bit of 2 years worth of corn residue, soybean out there at 125, wheat at 300. Sometimes that's what's tying up our sulfur. So when a guy says, how much sulfur do I need? Well, what kind of a residue management program do we have? Second thing here is talking about the hydrogens, right? You got to have carbon, hydrogen, and oxygen to make those sugars. And what I've always asked people about their base saturation of hydrogen, and a lot of people look at that. If my H is 0, how am I going to form those sugars, right? And again, oxygen, everything needs oxygen to move. And back to where the water is, or the water's placed, whether we're talking about the nitrogen, whether we're talking about potassium, selenium, some of these other things that have to have water to move, then they've got to be where the water is, or the roots can't get to them. Nitrogen, we'll go back in here, and nitrogen's a wonderful thing until we abuse it and we plug our roots in those things. And that's why, it's all about balances, ratios, and it doesn't do me good to eat protein one day, carbohydrates the next day. It goes back to, I'm going to make cake this weekend, so I'm going to eat eggs on Monday and flour on Tuesday and sugar on Wednesday, and hopefully by Friday I got enough stuff in there to work with. That's not how nutrition happens. So I've just got a lot of these things in here people can go back and look at. When we were looking at phosphorus, a lot of the guys want phosphorus all the time, just a little bit every time we're going out there, just a little bit of boron every time we're going out there. Some of these things that are mobile and will get away from us, we have to keep reintroducing them, just like we do the biology. If the phosphorus is short, then we're not going to have enough root structure going out there, and we're going to always be looking for it. A little bit of the deficiencies, potassium, I've talked many times about this stuff being hard to get in late. So we want to go out there somewhere in that V16, V18, be sure every one of these things that we're looking at are going to be in there to where we can have the ultimate fertility program that is going to be best to hang on to all the seeds that we pollinate, whether it's the beans and we're trying to keep all 3 of them or all 4 of them or both of them in there to swell up. It's what we're trying to do on corn. We've set our rows around, we've set our length, and now our job is to see how many of those we can hang on to. Molybdenum comes in there. That's part of what helps us assimilate the nitrogen back in there. Here's some good reading on molybdenum. Magnesium, more late than early, maybe, but goes in there and talks about basically it goes from the older to the younger tissue sometimes, but it also helps, with the calcium and things of regulating, making things work. Right. Manganese, needs to be on there to keep the blooms going on the beans. We tend to focus on the corn in these discussions. We don't always talk about the beans. Nickel goes back to the urease. If we happen to be using urea, not just UAN or not just anhydrous, then we got to be sure that we got some nickel in this thing. Boron for movement every time. Boron also helps moving some of the chemistry that we're trying to kill the weeds with back into there. Calcium tends to be a challenge to get inside of a plant in season. We talk about what is our pH, where's our calcium levels, but it also is the calcium form. Calcium carbonate isn't always the answer. Calcium tied into magnesium isn't always the answer. We've got to have free mobile calcium going in here. A little bit of chloride. Chloride's my friend. Chloride's my enemy, right? A little bit to move things around is a wonderful thing, but too much chloride is going to be detrimental and keep other things from moving. Copper is going to be part of my health thing, and we talk copper and zinc ratios. I like to see about 4 zincs to a copper. We get in here and cobalt, which is like B12, and we don't always think about plants needing vitamins, but we have water soluble vitamins inside the plants. We also have fat soluble vitamins in the plants. When's the last time somebody asked you if you had enough omega oils in there to make your fat soluble vitamins work? We use sulfur, to talk about adjusting the pH and some of those kind of things. Sulfur is part of every living cell. Part of why it's so important. We've got to have iron, but iron 2 plus is the one we're looking for. It helps hold the aggregates together. It's the one we need for the cation exchange capacity to work the way. It's a component of most of the enzymes that are associated with the energy transfer. And so we're not just moving nutrition. Growing plants is also about energy conservation. Every time we can do something for the plant that keeps it from wasting energy, we can divert that into yield. And that's just kind of a quick overview on what I was going to do on this part of it. And see if I can figure out how to stop sharing that, turn it back over to you guys, answer questions. And I would like to see this thing a little bit, question driven. What did people show up here today to learn, and what can we teach them?
So Brad, David actually had a question said, when would you use plant sap test based on what the water graph shows?
So the water graph is going to show me that I have an opportunity to make a change. We're not waterlogged. We're getting ready to, maybe to either irrigate, or we're going to have to come back because we know we have a deficiency, and that sap, separate from a tissue, is looking into the pantry, and do we have enough of the materials we need to facilitate the next major energy draw from the plant. So sap's looking forward. Tissue says, did we do a good job last week?
And so that's a timing and a growth stage thing. As far as the graphs go, if I'm seeing a stair step, that's the plant drinking. If I'm seeing a big stair step, it's drinking a lot. And so it's very active. And logically, I would think that, when it's not active, when you're not seeing a lot of activity, then you're not going to really see much in the sap. Whereas when you're seeing a lot of activity, then it's going to be cycling through. But have you got a comment on that, Brad?
I think that when we see that rapid growth, not only is it down there looking for moisture, it might be looking for something it hasn't found yet. It's on a scouting expedition. If it's looking for selenium or cobalt or moly or one of these other micronutrients and it hasn't found it, it's going to continue to get marching orders through that exudate. Say, I asked you to do this yesterday, you haven't do it. Did you not understand, or can you not find it?
Yeah, so I can actually go back to last week when root activity, and that might be exactly what we saw with some of the some late root activity where things really picked up. Once again, if I'm seeing something happen here that is makes me want to scratch my head a little, that could be why. And so if I just share this real fast, this is from last week, but if we start to look at these circles where the root is really active, now I can tell that's chasing moisture. There's no question, because it goes dry, and as it goes dry, it's looking for moisture at the next level. But what's going on over here, and exactly what you're saying, it's suddenly, I don't think it's, yes, the crop is getting dry for sure, but I think it's also active for another reason. And as you say, maybe looking for something.
Maybe looking for potassium, magnesium, or one of those things that needs really late.
Yeah. So that could be an indication that it's seeking something out. But coming back to the question, when would you, look? What's the timing of this. I mean, I think you can certainly tell, when that crop gets super active, and that's those stair steps really increase. I mean, it from the growth stage anyway. Um, you know, then you can start to use that for timing of your sampling. But I would suggest that it's when it is really growing is when you're going to get a better sap test.
And I would think when we see one of those, even if we're late this year, then that would be something to start looking for as soon as we see that lower level stair stepping. Let's go back and see what we might have been short of the last time we saw that. Start building our historical database.
Because once again, this isn't just an irrigation tool. This is root zone monitoring. This is what looking at what's going on inside the plant where you can't see it. You can't really sample it. So it's there was another question as well in the chat that was about best to have more water out before planting in a dry condition. I always like to plant into moisture, and so I say that from what I've seen, as come back to the roots not growing into the dry soil. I've met a lot of farmers that say I don't pre-irrigate. I'll put the seed in and then I'll water it up, but you've got to have enough capacity to put more on than what the crop is using early, but in a way that still promotes root growth. And that is if you irrigate less frequently and much more deeply. And so that's the way that you could do that.
Let's go back and talk pre-irrigating to have adequate moisture so that every seed out there can draw in its 1/3 or 1/2 of its weight in moisture to have a chance to come up the same day. If we're sitting there with uneven moisture and then trying to wet it, we're still probably going to uneven wet it. And that is not going to give us that perfect picket fence stand that we're looking at, so they don't perceive each other as as a challenge, as an enemy.
Because even if you're running fast to germinate the crop, it's probably still going to take you 24, 48 hours to get around with the pivot. So that's going to cause some unevenness. So keep the questions coming, because that's the way we can sort of tailor things to what you need to know. But Alan, did you have some other comments or things that we've missed?
Yeah, just a couple of things here that we can talk about as we wrap up. Two things that I would really hit home on is, number one, the need for oxygen in the profile during that pollination period. There's an oxygen demand in there that we don't oftentimes think about. So it is getting that moisture content right. Yes, we need moisture in that profile. We also need to have airspace in that profile. And part of the reason behind that is maximum water uptake. We want the plant to transpire a lot of water through pollination. We need that plant to be really healthy, and a really healthy plant is transpiring at a high level. And that is one of the things that I'm watching for very, very closely. Typically, there's 3 phases that I'll try to manage water on if I'm irrigating. If I'm tracking, let's say, even to manage for marketing, managing the potential for high-end yield production, to determine, am I going to have a high yield? Am I going to have one that's going to be struggling a little bit? I'm watching the prepping to pollinate phase where I'm developing a root zone. This phase, the pollination period, I'm watching that very, very closely. And then the ear fill stage, which we'll talk about next week. Each of those individual stages are, if you're irrigated, you're managing those a little bit differently. If you're in the rain-fed environment, the soil health and soil structure is absolutely critical, because you're going to be still managing water. You still want to be marketing and selling based on water capacity or water availability, but you still want to be able to say, hey, I'm doing the right thing. Whether I'm irrigated, whether I'm rain-fed, I'm doing the right thing to increase capacity of the soil structure so that I can increase access to oxygen. I've seen that over and over again. And I know, David, you have too, where I've seen graphs as many as 4 or 5 days in a row where the plant is actually stressed, and then it goes into real high transpiration. And during that period, we want plants to be transpiring at a very, very high level. So that's one of the things we're looking for is what's the moisture content? What's the moisture to oxygen ratio that keeps that plant transpiring very aggressively during pollination? Can you verify that, Dave?
Too much of a good thing. Just, um, yes, the crop needs a lot of water during pollination, but you can get it wrong. And so even if you've got a high capacity and you still want to run it, running it, spacing things out a little more so that you give the plant more time to dry the soil out and then wet it back up, it's probably going to be a better scenario than just wetting it up and keeping it wet to the point where it's waterlogged and there's no oxygen in the soil.
One thing I'll put in here, I had hoped to have the numbers that I would be typically looking for in a tissue test up today. I answered the phone a couple of more times than I should have. So I have finally learned that on these days to shut the phone off, and then you're not tempted to talk to anybody until the Zoom meeting is over, and I will have those numbers for the next one.
Very good. Very good. I understand that approach, Brad. I might have been one of those phone calls. All right. Well, guys, this has been very good. If we have any other final questions or comments or feedback, pushback, I'm even open to pushback. If you're seeing things that maybe we're not quite getting right here, you see a different perspective, we want to hear that too. We want to hear your thoughts. So, any other final thoughts or comments? Not, we'll start getting wrapped up and prepare for next week. So next week, everyone, will be our final session on this group or this series, and we're going to be talking about that ear fill and going into pollen, going into harvest. And I really, really believe that time is when we are thinking about next year. It's during the harvest, during the reaping of the harvest, that we're going to be able to actually drive into some of the highest yields, the highest profitability starts in the combine seed. It doesn't start at planting, it starts in the combine. And that's something that I've also learned over the course of time. Now that we're looking at permanent data, we're looking at long-term, continuous, unbroken data from the root zone. I'm seeing it more and more and more, especially from a soil health perspective as it pertains to profit farming. If we're farming for profit, that long-term continuous root zone data is absolutely priceless, but also building our plans, starting our cropping system in the combine, not the planter, really makes a big difference. Do you guys have any thoughts on that?
I've certainly met a lot of farmers that they want to be in the combine because they want to see where the good spots are and the bad spots are. It's how you get to know your field. And some of the better farmers that I've worked with, they always try and work out why the poor spots aren't performing, because the good spots, will look after themselves. But you got to try and work out what's going on with those, the poorer performing areas. So if you can lift them, it'll bring the whole average up. That's been my experience. You were going to say something, Brad?
I was just going to interject that don't let the possibility of buying a bigger grain cart talk you into losing all the oxygen that we have built up into that soil throughout the season too.
Again, too much of a good thing. David had a comment about putting, have everything available before it's demanded by the crop. And my counter to that is that if you do too much, if you've got too much of a good thing when it comes to irrigation, and you start too early and go too hard, then you can actually be counterproductive and create a shallow root system. So yes, you absolutely need to have things available there when when the crop needs it, including a deep root system. And so that's so yes, I totally agree with it, but you've also got to do it in a way that creates a big root system, because so many people get that wrong or think, hey, I only need 20 inches of roots. But it's a bit like using 3% of your brain. Imagine if you could use 10% of your brain, you'd be a genius. Same with the crop. Maybe you can, get an extra 20, 30, 40 bushels out of that field if you took the time to actually work out how to get a bigger root system. And that's where that continuous root zone monitoring comes in. It's not a silver bullet. It's a way of understanding what you're doing so that you can then work out how to modify things and move forward. So, continual improvement.
And
Yep.
and on the nutritional side of that, for an extra 5,000 a year, you can join one of these groups that you're donating all of your information so they can assemble those numbers and hope that they give them back to you. Because that's kind of David's number, and so the numbers I'm going to present the next time we get together will be from the limited scope of data that I have, and I can kind of tell you if we're shooting for 300 plus bushel corn. These are the numbers that we did not fall below going across some of these micronutrients. At a 285, these are some numbers we didn't fall below. And I think that's kind of Dave's question, because as we send in tissue samples or sap samples, and they're not giving us back information based on what was my yield goal because they didn't ask. So historically, we have done more tissue sampling on problem areas. So what we're finding out is we're better than 50% of the problem farms in the last 50 years.
Brad, one last thing. I know it's we're going past the hour, but I've
Yep.
been to a lot of meetings, and this is it's in the Western Corn Belt where they talk about post-tassel nitrogen application. All the highest yielding farmers, that's what they do. You got a comment on that?
Yeah, they don't give up. There's no reason to have dent corn. Corn was made to look like popcorn, and it shrinks and we have the dents in there because we gave up on it before it gave up on itself.
So, any comment to what percentage of your nitrogen application could be post-tassel?
It goes back to, we used to have something that we were doing here in the Midwest where we would go down there at a 0 to 12. We'd say, since the last nitrogen applications, how's it moved? What form is it in? How much of it's left? And so again, kind of gets back to how good a job did we do stabilizing it? Is it where we can access it? What forms it in? And, before we talk about just how much, it's, looking at some of these other things. What's there? How much do we need to supplement? And what form is it going to be? And I've heard people talk, this slow release nitrogen on the leaf. Typically, if I'm going to put nitrogen on a leaf, I don't want it to work in 2 weeks. I mean, it's time to work. So I don't know why we would talk about putting a slow release on a leaf.
Yep. Good point. Well, guys, this has been great. I do appreciate everybody jumping in. I know several had to jump off for work and other things. So again, appreciate you being here. Next week, we're talking about harvest. That's the reaping of our harvest, the reaping of a strong, profitable crop. And then we'll start talking about what we're thinking. Where's our headspace at as we're putting residue behind the combine? We're thinking about the biology staying active over the off season. What are the things we really want to be thinking about from the combine seat? That'll be some of our discussion next week as we end this series, Farming for Profit. All right, guys. Thank you very much. Brad, David, thank you for your insight. And we'll see you here next week.